Hello and welcome to another video. Today we will look at circular queues. In the previous video, I have introduced what is a circular queue. Today we will look at a program using arrays. So we will look at implementation of circular queues using arrays, right? So normally a C program or usually a C program starts from the main function, right? So let us look at the main function here. So Enqueue represents inserting elements into the queue, right? Queue is a first in first out data structure. So here we have 1 2 3 4 enqueues here, which means that I need to insert elements 10 20 30 and 40, and the maximum number of elements in this program are 5. So what I'm going to do here is that I'm going to first call the enqueue function. As we can clearly see here, the enqueue function is being called here, right? Enqueue function is being called here. So first we will call the enqueue function. So I'll move quickly to the enqueue function, right? So this is our enqueue function. I will just draw a queue here of maximum of 5 elements, right? So here maximum of 5 elements, 0 1 2 3 and 4 here, right? So we know that initially front equal to -1 and rear equal to -1, which means that initially both front and rear are pointing towards -1, right? Which means that there are no elements in the queue. As we all know, queue is a first in first out data structure where insertion takes place from the rear and deletion takes place from the front. In other words, enqueue takes place from the rear and dequeue takes place from the front, right? So first of all, the enqueue function is called here the enqueue 10. So we have seen, right, we have seen that there is enqueue of 10, which means that value is 10. Then before inserting, we will check whether the queue is full or not. If the queue is full, we will say overflow condition. If the queue is empty, then we would like to insert, or if the queue has elements and if there are spaces in the queue, then we will insert elements. Similarly, while dequeuing, while deleting element, we will check whether the queue is empty or not. So while inserting, we will check whether the queue is full or not. While deleting, we will check whether the queue is empty or not. So here, while entering into enqueue, we will call the isFull function. So let us go to the isFull function here. Here isFull, right? So here we will check whether front equal to 0. The front is not 0, right? Front is 1. Front is -1. Therefore here, because this is false, we do not need to check this, right? So once it is false, and because we have the and logical and operator, this whole expression or the whole condition becomes false, right? This whole condition becomes false here. So I can just say this whole condition is false here, and or I'm saying rear plus 1 equal to font. So rear plus 1, rear is -1, -1 plus 1 is 0, equal to front is -1. Therefore this is also false. So false or false is nothing but false, right? False or false is nothing but false. Therefore this whole condition is actually false. So whenever I have false here, I will return 0. So here 0 is returned here. Here 0 is returned. Here 0 is returned. Therefore it will not go inside the if statement and it will come to this place. Now I will check whether it is empty or not. If is empty, the isEmpty function is called here again. Let us go to the isEmpty function here again. Now here I will check whether front equal to -1, right? Is front -1? Yes, initially front is -1. Therefore I am saying here return front equal to -1, which means that this gives you a true or a false, right? So because front equal to -1, it will return true. When I say it will return true, it will return 1. True means 1, false means 0. This function returns an integer value, right? So here is empty will actually return 1. Therefore, it will coincide and say front equal to rear equal to 0, which means that both front and rear now will point towards 0. Right? So I will just change the pointer here for both of them. Now front and rear both will point towards 0. Right? So after this, after executing the if statement, it will directly go here, this statement, right? It will directly go here and value is 10. Therefore, q of rear becomes 0. Therefore, q of 0 equal to 10. Which means that this is an assignment operator. Therefore, right hand side to left hand side. Therefore, 10 will be stored in q of 0. Where q is basically the name of our array, right? Q is basically the name of our array. Therefore, q of 0 is nothing but now 10, right? So I'll just print out saying inserted 10. Therefore, in the output, 10 will be displayed. Right? So after this, we again would like to insert enqueue of 20. Now front is equal to 0 and q is 0, right? Let us remember that. Now again what happens is that again the enqueue operation is called, enqueue function is called, and we will check again whether the queue is full or not. So let us go again to the is full condition, right? Now here front equal to 0 is true, and rear equal to size minus 1. So rear is 0, is 0 equal to 5 minus 1, that is 4. This is false, right? This is false. So here again true and false will actually give you false, right? Or rear plus 1 equal to front, right? So rear plus 1, rear is actually 0, 0 plus 1 is 1 equal to front. So front is now 0. So 1 equal to 0 is false, right? Therefore false or false will actually give us false. Therefore here this function returns false, which means that it will return 0. Now I'll go here again. So again it's the same, it is returning 0 here. So therefore it will not go into if statement, right? It will come out of the if statement, and again we will check whether it is empty or not, right? Again the isEmpty function is called here. Let us go to the isEmpty function. Now here it will check whether front equal to minus 1, but we know that front equal to 0 right now, right? Therefore this will return false, which means that this will return 0, right? So here I'll replace 1 by 0, right? Therefore it will not go into the if statement here. It will go into the else if statement. So what is there in else if? It will check whether rear equal to size minus 1. Size is 5. So rear is 0. Is 0 equal to 4 is false. Therefore once one condition is false, the whole condition is false, right? Therefore it will not go into the else if statement, it will go to the else. So else there is only one thing, rear plus plus, which means that rear now will become 1. Therefore rear now will point towards 1, right? After pointing towards 1, the value is 20, and now rear is 1. Therefore assigning right hand side to left hand side, q of 1 equal to 20, which means that 20 will be assigned to q of 1. Now front equal to 0 and rear equal to 1. Now if we try to insert 30, what would happen? Again the same thing, we will check whether q is full or not. So let's check it again. Okay, here I have front equal to 0. Front is 0 is true, right? And let us check whether rear equal to size minus 1. Rear is now 1. Is 1 equal to 5 minus 1, that is 4, false, right? So here we have false here, and true and false will give us actually false, right? And let us check this one. Rear is now 1. 1 plus 1 is 2 equal to front. Front is 0. Therefore this is false, right? Therefore false and false or false is actually false. Therefore it will return 0. False means it will return 0. Here it is going to return 0. Therefore it goes again to the if statement here is empty. It will check whether it is empty or not. Quickly, is empty, return front equal to -1. Front is not -1, therefore it will return 0 again. It will return false, that is 0, right? Again it will return 0. It will not go into this if statement. It will not go into this if statement. It will go into the else statement now. Else if statement, sorry. So now here it will check whether rear equal to size -1. So what is rear? Rear is 1. Rear is 1 here, equal to size -1. Size -1, 5 minus 1, that is 4. Therefore this is false, right? Once it is false, the whole else if becomes false. Why? Because there is a logical and operator there. Therefore it will not go here, it will go here again to the else, rear plus plus. Therefore now rear will become 2 here. Rear will become 2, and then I will point towards 2. Once I point towards 2, then I'll say q of 2 equal to 30. Q of 2 equal to 30, right? Therefore 30 will be inserted here. Now we can clearly see that front is 0 and rear is 2. Now suppose I say enqueue of 40. What is going to happen? The same thing again. The enqueue function is going to get called. Value is 40. I will check whether it is full or not. Okay, full. Let us check again, right? Let us check here. Now we can clearly see that front equal to 0 is true, and rear equal to size -1. So rear is 2, equal to 5 minus 1, that is 4. So this is false, right? So here true and false will actually become false, right? This is false, therefore true and false will actually become false here. Or rear plus 1 equal to front. So rear equal to 2, 2 plus 1, 3 equal to 0 is actually false. Therefore false or false is false, right? This is false, therefore false and false is false. Therefore here this return false, that is 0. Therefore here it returns 0. So I'll go here, right? This point again, here it is 0, correct? Now it will come out of the if statement. It will go into the if statement here. It will check whether it is empty or not. We know that it is not empty because front is not -1. Therefore again it will return false, that is 0, right? Therefore it will not go into this if statement. It will go into else if. Now let us check what is else if statement here. As we can see here, rear is now 2, equal to 5 minus 1, 4, right? This is false, which means that it returns 0 here, right? Therefore it goes out of the else if, it comes into the else statement, rear plus plus. Actually once it is false, it doesn't return anything. Basically it goes out of the else if statement and it goes into the else statement. And now I change the pointer here. I say rear equal to 3, and now rear will now point towards 3 here, right? After pointing towards 3, now rear is now 3, equal to 40, which means that I will insert here 40. Now the enqueue operations have been completed as in the program. Now let us go to the main function here and see. So all these 4 enqueue operations here have been completed successfully. Now I call the display function. Let us see the display function here, right? So here, as you can see, display, it will check whether, first if you want to display, it will check whether the list or the array is empty or not, right? So we know for the empty condition, front equal to -1, front equal to -1, right? So front is not -1. Now in our program, front is now actually 0. Therefore this doesn't hold. Therefore we come out of the isEmpty function, right, if statement, and then we print out elements of the queue. How do you print out? First we check whether rear is greater than or equal to front. Now we know in our example here clearly rear is 3 and front is 0. Therefore here, as we can see here, rear is greater than front. Rear is 3 and front is 0. Therefore here rear is 3 and front is 0. Therefore it will go here inside the if statement, and there is a for loop here, I equal to front. That means that I equal to 0, I is less than or equal to 3. Therefore it will print out first q of 0, that is 10. It will print out, then I will increment, I will become 1, right? Then 1 is less than 3 is true. It will come inside this state is loop and print out q of 1, that is 20. I will be incremented, I will become now 2 here. 2 is less than 3, true. Therefore it will print out 30, and then I will become 3. 3 equal to 3, then it will print out 40. Therefore 10, 20, 30, 40 would be displayed, right? So display function is already done right now. Then we call the dequeue function. So dequeue function is nothing but deleting elements. Now what happens if we call the dequeue function? So let us go again to this dequeue function, right? Dequeue function. Now here I am going to draw the same queue as I have drawn above, so that we will see how we can dequeue, right? So we have inserted 10, 20, 30 and 40 here, and then front is equal to 0. So 0, 1, 2 and 3. So front equal to 0 and rear equal to 3 and rear equal to 3, right? So now we have the size of the queue is 5. Therefore there is one more element to be inserted. Therefore the maximum size is 5, right? So 0 to 5. Here clearly you can see that there is one more element to be inserted, right? The queue is not full there. The queue is not full. As we know FIFO, in a queue, the insertion takes place from the rear and deletion takes place from the front, right? So front is now 0 at this position and rear is now 3. So now what happens if we call the dequeue function? So first it will check whether the queue is empty or not. So we know the empty condition, right? Front equal to -1. Is front equal to -1? No, false, right? Therefore it will not go into the if statement. It will come here. So I'll say int value equal to q of front. Front is now 0. Q of 0 is nothing but 10. Therefore before deleting, I just want to store the value in a particular variable, and this variable is nothing but the value variable, so that we can display it. So after deleting, there is no way to display the value. Therefore before deleting only, I am storing it in a variable called value, and then I would be deleting. That is the reason I am storing q of 0, that is 10, into a variable called value. Therefore now value will have 10, right? 10. Now I will check if front equal to rear. Obviously front is not rear. Front is 0 and rear is 3. Therefore it will go into the else if statement. Now here front equal to size minus 1. Front is 0 and size is 5. Therefore that is nothing but 4. 0 is not equal to 4. Therefore it will go to the else statement. Else statement clearly says front plus plus, which means that front will be incremented by 1. Therefore here front will become 1, and then now I am pointing now towards this place, right? Now because I have incremented front, now front has moved from 0 to 1. Therefore here 10 is garbage collected. Front is now not pointing towards 0. Therefore this is garbage collected and 10 is deleted, right? Therefore I can say deleted value 10, right? 10 is deleted. Similarly, again, if I call the dequeue function, so in our program there are two times where we call the dequeue function. We can call it any time, but just for the sake of explanation, dequeue function is called twice, right? Now here first dequeue function is done, so I'll just write here dequeue. This is done. Now again I am calling the dequeue function, right? Again I am calling the dequeue function. Again we will check whether it is empty or not. Front is now 1, right? Therefore front is not -1. 1 is not equal to -1. Therefore it will go here, and I am saying int value equal to q of front, q of 1, that is nothing but 20. Therefore now I will store 20 inside value, right? If front equal to rear, obviously front is 1 and rear is 2, therefore this does not hold. Now I'll come here, front is now 1, 1 is not equal to 4, therefore again I will go here, I'll say front plus plus. Now front will become 2, front will become 2. I will just point towards, I'll just point towards 2 here, and then now 20 is garbage collected, 20 is garbage collected. I'll just print out 20 here, I'll just print out 20. Therefore here, after calling Dequeue 2 times, I have deleted 10 and 20. Now front is pointing to 2 and rear is now 3. Please remember, front is 2 now and rear is 3. Now what happens if I want to insert, that is what our program says. If I want to insert an element right now, right, suppose I say now here, so now after Dequeue I am saying display here. So let us again call the display function and see what happens here again, right? So here we have the display function. I will check whether it is empty, right? Front is not -1, therefore it is not empty. So now the important thing is to check what is the value of rear and front, right? Rear and front. Now here, as we can clearly see, rear is 3 and front is 2, right? So rear is 3 and front is 2. Rear is greater than front. Therefore I equal to front. So I equal to 2, right? And 2 is less than or equal to 3. Therefore it will print out Q of 2. Q of 2 is nothing but 30 will be printed. Then I plus plus, I will become 3. 3 is equal to 3. 3 is equal to 3. Therefore Q of 3 will be displayed here, and then 40 will be displayed, right? Then I will become 4. 4 is not less than or equal to 3. Therefore it will come out of the for loop. It will come out of the for loop, and the elements that are displayed are 30 and 40, right? Therefore that is how we finish off with the display function, right? Now I say Enqueue 50. There are two Enqueues now, Enqueue 50 and Enqueue 16. Let us see what happens here. Let us see what happens. Again we'll go to the top here. Yeah, we'll go to the top here. So we have finished with the Dequeue, right? We have finished with the Dequeue. Therefore I can just delete like this, and I will say here front equal to 2, and I will repoint the front to 2 here, right? Now front equal to 2 and rear equal to 3. Now I am saying Enqueue, I will write here Enqueue 50, and then I will call Enqueue 60. First I will call Enqueue 50. So once I call Enqueue 50, 50 would be here, right? Now I will check whether the queue is full or not. Let us see now, correct? So now here I will check front equal to 0. Front is now 2. 2 is not equal to 0. Therefore it is false, right? Therefore it is false. And once it is false, if you have a logical AND, the whole condition becomes false. And now here rear plus 1 equal to front. So rear is 3, right? Rear is 3. 3 plus 1 4 equal to front. Front is now 2. Therefore it is not equal. Therefore this is also false. False or false will give us actually false, correct? Therefore here it will return false, which means that it will return 0, right? So it will return 0 here, right? 0 is already there here. Therefore I will not go into the if statement. I will check whether the queue is empty or not. We know the empty condition, front equal to -1. Front is not -1, front is 2. Therefore we will go to the if statement. Now we will check whether rear equal to size -1, right? So rear is now 3 equal to 5 minus 1, that is 4. So here this is false, right? Therefore it will not go into the else if statement here. It will go directly to else. I am saying rear plus plus, which means that rear now will become 4. I will repoint it now again to 4 here, right? 4 here, and then I will say Q of rear, Q of 4 equal to 50, right? So I will just insert 50 here, and I will print out inserted 50, Now again, if the enqueue function is called, which means that value will become 60. Now please listen, this is very important. Now we have to insert element inside the 0th index. So now the queue is full, linear queue is full, but the circular queue is not full, right? In the circular queue you have empty spaces. Therefore the queue should not be full. We have to write a program in such a way that we should be able to allow the user to insert element in the 0th position. So let us see whether the program is correct or not, right? So now here Q is 60 here, right? 60. Now E is full. The E is full now should become false, right? E is full should not become true. Let us go to the E is full condition here, right? E is full function here. So now here front equal to 0, right? Front is not 0, so this is false. Rear plus 1 equal to front. So let us see what rear is. Rear is 4 now, right? So 4 plus 1 is 5. 5 equal to front, right? So front is now 2, right? Front is now 2. So here this is also false. This is also false. Therefore false or false will give us actually false, that is 0. So it will return back 0 here. It will return back 0 here. Therefore it will return back 0 here. Correct. Therefore again we go to the is empty condition. Is empty. What is the is empty condition? Front should be -1. Therefore front is not -1, front is 2, right? Therefore it will go now to the else if condition. This is important, right? This is important. Now here we will check whether rear equal to size -1. Rear is 4. Is 4 equal to 4? Size is 5, right? 5 minus 1 is 4. It is true, right? Now front is not equal to 0. Yes, front is not equal to 0. Front is 2. Therefore this is also true. This is true and true. Therefore true and true is true. Therefore it goes inside the else if, and now it says rear equal to 0. So now from rear equal to 4, rear is now becoming 0. Rear is now becoming 0. Correct? Therefore in linear queue it would say that the queue is full. Now here in circular queue we have written a program in such a way that now rear is pointing towards 0, right? Once it is pointing towards 0, I am saying here q of rear, q of 0 equal to 60. Therefore here 60 would be inserted. 60 would be inserted, right? I hope you are understanding this, right? So after this again suppose I call the enqueue function. So let us see what our main function says, or what are the functions that are there in main function. So after inserting 60, again I have the display function here. So after inserting 60, I'll call the display function. So let us check whether it is empty or not. So empty condition says that front should be -1. Here front is 2. Therefore this condition is false. It goes here. Now we will check whether rear is greater than or equal to front, right? Rear is 0 and front is 2, right? So here rear is 0 and front is 2. Therefore this condition is false here. It goes to the else condition. In the else condition we have I equal to front, right? So I equal to 2. 2 is less than 5, right? So therefore here q of 2 will be displayed, that is 30. Then I will become 3 here. Then 40 would be displayed here. I would become 4 here. Then 50 would be displayed. Then I will become 5, and when I becomes 5, it just comes out of the for loop and goes to another for loop. Here we would like to print this 60 as well, right? Therefore this 60 as well. Therefore I am saying here I equal to 0, I is less than or equal to rear. Rear is now 0, right? Therefore 0 is less than or equal to. Therefore 0 is equal to rear, that is 0. 0 is equal to 0, right? Therefore this is true. Therefore q of 0 will be displayed, that is 60 will be displayed. I would become 1. 1 is not equal to 0. Therefore it comes out of the loop. That is how we displayed 30, 40, 50 and 60. Whatever elements are there in the queue have been displayed, right? Now again let us go to the main function and see what is the next function. So we have enqueued 50, we have enqueued 60, we have displayed all the elements, so, right? So what are the functions that we have done? We have done these four functions. 10, 20, 30 and 40, displayed 10, 20, 30 and 40, dequeued the two elements, right? Dequeued the two elements, that is 10 and 20, and then we displayed whatever elements are left, right? That is 30 and 40, and then we enqueued 50 and 60, right? And then we displayed what are the elements that are displayed: 30, 40, 50 and 60, right? Therefore now we would like to now again insert 70 here, right? We would like to insert 70 and see what happens here, right? So if I go here and try to insert 70, let us see what happens. So if to enqueue it, we call the enqueue function. Let us go back to the enqueue function. Here, if we go back to the enqueue function, we would like to now insert here 70. What happens if we insert 70 here? Is full, right? Let us go to the is full condition. Is full. This is important, right? We need to check whether the queue is full or not. If the queue is full, then overflow. Obviously, the circular queue here is not full, right? Therefore, it should allow us to insert element here. So this should become false, right? Therefore, front equal to 0 is false. Front is 2, we know, right? Therefore, here this is completely false, and here rear plus 1. Rear is now 2. 2 plus 1 is 3. 3 equal to front is now 2. This is false, right? False or false is false. Therefore, here it returns 0. It returns 0. So here in the enqueue function, inside the enqueue function, there is a is full function that is called. It returns 0. Therefore, it will come out of the this if statement. It will go into this if statement. If is empty, front is not -1. Front is actually 2, right? Therefore, it will go out of this if statement and it will go into the else if statement here, right? Now let us check out this else if statement, right? So rear is now 0, equal to size -1. 5 minus 1, that is 4. This has become false. Therefore it will not go into this else if. It will go to the else statement, rear plus plus. Therefore here rear now will become 1. Rear now will become 1. So rear now will point towards here. Rear now will point towards here, right? Rear now will point towards here, and then front is anyways pointing towards 2 here, and rear is now pointing towards 1. Therefore here q of rear equal to value here rear is now pointing towards 1. Therefore q of 1 equal to 70. Therefore I would be inserting here 70. Now front is pointing towards 2 and rear is pointing towards 1, and we can see the queue is actually full now. So if I try to insert any other element here, it should say actually the queue is full. For example, let us go down here into the main function and let us add one more function here. Suppose after this I say enqueue 80. So it should not allow us to insert. It should say the overflow condition. It should give us the overflow condition. So here let us again call the enqueue function here, and then now is full function now should become true here, right? Is full should become true. Therefore I would go to the is full function. Let me just erase this whole thing right now. So therefore here front equal to 0, right? Front equal to 0. Now front is now 2, right? Front is now 2, which means that this is false. And so if it is false, this doesn't matter the second condition, right? This whole thing is false. And now here rear plus 1 equal to front, right? So what is rear, guys? Here rear is 1. So 1 plus 1 is 2, and front is also 2. Therefore 2 equal to 2 is true. Therefore false or true is nothing but true, which means that it will return 1 here. Therefore here it will return 1, and now I'll say queue overflow cannot insert 80. That would be displayed here. It will not be able to display or insert 80, because the queue is actually now full. So when is the queue full? When actually this condition holds, the is full condition holds, which means that when rear plus 1 equal to front, then the queue is actually full. So this is a very important condition here, right? So when rear plus 1 equal to front, when rear plus 1 equal to front, then the queue is full, then the queue is full, right? Then the queue is full. Now after this, suppose I want to dequeue elements, right? After this, suppose I have 4 dequeues here, dequeue, and dequeue. So I want to dequeue it 4 times, which means that now I will delete the 4 elements. So then let us call the dequeue function here one more time, right? Dequeue function, I'll just delete this, right? Let us do it comprehensively, right? So again here as well, I will exactly replicate this here, right? So 60 here, and then here there is 70, and then as we can see here, front equal to 2 and rear equal to 1. Front equal to 2, but I'll change the position of rear here. Rear will become 1. So front will become 2 and rear will become 1, right? Now I'll try to dequeue. So in dequeue we call the isEmpty function, right? IsEmpty means that the front should become -1. The front is not -1, therefore it is not empty. Therefore it will go to the if statement. It will come here. Before deleting, we need to store the value store the value in a particular variable. Here the variable itself is value, right? Therefore here I'm saying value equal to q of front, that is q of 2. Therefore here, if I want to delete, deletion should take place from the front, right? Therefore here 30 would be deleted. Therefore I'm first storing the value of 30 here, and then I'm saying if front equal to rear. Front is obviously not equal to rear, right? Front is obviously not equal to rear because front is 2 and rear is 1. Therefore it will not go into the if statement. It will try the else if statement, right? Else if, right now front is 2, and it will check whether it is equal to size -1, that is 4. It is not. Therefore I'll say front plus, which means that now front will become 3. Which means that I'll just point it towards 3 here, right? I'll point it towards 3, right? It is not pointing towards 30. Therefore this is garbage collected. And rear is still pointing towards 1. Correct? Now again if I call the dequeue function, front is not -1. Therefore I will store the value of 40 here, q of 3, right? q of 3, therefore that is 40. Therefore I will store the value of 40 here. So here int value is equal to q of front is now pointing towards 3. Therefore q of 3 is nothing but 40, right? Therefore I'll store the value of 40, and then I'll check whether front is equal to rear. Front is not equal to rear. Therefore it will come here else if front equal to size -1. 3 is not equal to 4. Therefore I'll say front plus, which means that I will increment the value of front here, right? Therefore front now will become 4. Therefore front will now point towards 4 and rear is still pointing towards 1. Therefore this value, this 40, will be garbage collected. Now again I'll call the dequeue function. This is the third time we are calling the dequeue function, right? I'll write dequeue here itself. Two are done. I'm again calling the dequeue function. Again isEmpty, front is not -1. Therefore it will come here q of 4, right? Here it is nothing but q of 4. I'm storing the value of 50 here. Now if front equal to rear, front is not equal to rear, obviously 1 is not equal to 4. Therefore it will go here else if. Now this is the main thing. Now what is front? Front is 4 and size -1. 4 equal to 4 is true. Therefore it will wrap around. It will say front equal to 0. Therefore if I want to delete 60, I need to, if I want to delete 50, I need to point front now towards 0. That is the reason I'm saying front equal to 0. Therefore here front will now become 0. And rear is still pointing towards 1. Therefore here 50 will be garbage collected. And I'll print out deleted 50. Right? Now again if I call the dequeue function, this is done. Again if I call the dequeue function, what would happen? I should ideally move front to 70, right? Front is 0, front should become now 1, right? Therefore, let us see is empty, right? Front is empty condition is that front equal to -1. This is false, it comes here, right? So I'm saying int value equal to q of front is 0, therefore I'll be storing here, I'll be storing 60 in value. Then I think if front equal to rear, front is not equal to rear, right? Front is 0 and rear is 1, therefore it will go to the if statement, come to the else if here front equal to size minus 1, front is 0, front is here 0, and size minus 1 is nothing but 4, therefore this is false, it will go to the else statement. Now I'm saying front plus plus, which means that now front will become 1, which means that I will point front here. Now front and rear both are pointing towards 1, right? And now this value is garbage collected, now please observe that there is only single element, right? If I try to delete this element as well, then the queue becomes empty, therefore using this example we can actually say that if front equal to rear, then front equal to rear equal to -1. So when front and rear become -1, the queue becomes empty, right? Suppose if I call the dequeue function again, what would happen? Then what would happen? Ideally 70 should be deleted and then we should have an empty queue. Therefore, from this example we can clearly see that if front and rear both are pointing towards the same element, then we can say that front equal to rear equal to -1, which means that the queue is empty, right? So one condition from this example is that if front and rear both are pointing towards the same element, it means that there is only one element in the queue, which also means that if front and rear are both pointing towards the same element, I can say, if I want to delete that element, I can say front equal to rear equal to -1, right? I would like to repeat one more time. If front and rear both are pointing towards the same element, and if I want to delete that particular element, I can say front equal to rear equal to -1, correct? So again, suppose if I call the dequeue function is empty, right? Is empty condition says that front equal to -1, but front is 1, therefore it comes out of the if statement. And I'm saying if front equal to rear, right? So now this condition holds, right? It has not entered this condition, it came here, and I'm saying q of value equal to q of front, which means that value will now contain 70, and now it comes here, if front equal to this condition holds, therefore what I'll say, front equal to rear equal to -1, which means that I will now point front and rear to -1. I will now point front equal to -1 and rear equal to -1. Both are pointing here, therefore suppose this is -1, right? This is -1 here, just right here, this is -1, which means that it is not pointing towards the queue. That's what it means, right? It can be -1, -2, whatever. It is not pointing towards the queue, any element of the queue, right? Which means that our queue is empty, right? Empty. Now suppose if I call the dequeue function one more time, what happens? It should say that it cannot remove elements. Underflow condition should be called. Now again, I call the dequeue function is empty. Function says that if front equal to -1, as you can see here, right? Is empty function says that return front equal to -1. Front equal to -1 is true, right? Therefore now it returns 1, true, right? It returns true. Therefore let us go down here again. Here it returns true here. Therefore we will print out queue underflow cannot delete any element, right? Cannot delete element. Now our final thing is that we cannot delete element because we have deleted all the elements in the queue. So what we have done here in this example is that we have inserted elements in this circular queue, we have deleted the elements, right? And in a linear queue, even though we have spaces in the front, we could not insert elements in the front, right? But here in the circular queue, if there are spaces in the front, we have written a program in such a way that in a circular queue we will be able to utilize all the empty memory spaces in the front of the queue. That is nothing but a circular queue, right? I hope you have understood this implementation of circular queue using arrays, right? Thank you for watching.